All right. Welcome to the stream. As you all know, today we'll continue with the same thing that we were doing yesterday. I mean, we are not doing exactly the same thing, but we are on the same page. Perfect. All right. I'm set to program. Yep. Let's go. So yesterday what we did was, let's open up our project. Cool. So yesterday I believe we created this editor module and transferred all of the terminal code to this editor module. This was, by the way, I think assignment 1. So yeah. Let's see what we wrote yesterday in terminal. So in terminal we had an initialize. And we are calling this initialize from editor, right? Yes, terminal initialize unwrap. Let's also open up chat GPT. Okay, I haven't logged in yet. Let me just quickly log in to chat GPT. Chat GPT. Okay. Okay, let me also clear up my chat GPT history. How to clear that? How can I? Please. Settings, data control, memory. Chat GPT will become more helpful picking up all the details. Delete all chats. Yes. Yep. Now we are good to go. Or I could have just hidden that sidebar. Okay, let's ask chat GPT, what does unwrap do? In Rust, what does the unwrap function do? Explain in concise. Unwrap function is used to extract the value contained in an option. Oh, okay, I forgot. So that option can be either some value or an error. If it encounters an error, the program will panic and shut down. Cool. So we initialize the terminal. Let result equals self.repl. This REPL is the loop, the text editor loop that we are that is there, right? What is a text editor loop? The loop is you you capture the key event on your keyboard, like whatever key you are pressing, the program will capture that. This loop will check what is that event. If it is some of the like command key, like a colon or anything like that, it will do certain operations, right? It will do specialized operation like exit the program or exit the text editor, something like that. So that's what the REPL function ultimately represents. Let's also run this. I forgot to add tmux. This is my bad, but no worries. Okay, let me also, how do I focus on this? Focus. Terminal. Okay. So if I press F7, nothing happened, right? Oh, okay. What? This is crazy. Okay. Force right, close buffer, horizontal split, vertical split. Local leader key, what does that mean? So if I press F7 and I press here, in AstroVim I opened up the terminal, but I cannot write to it. I or A. Oh. So if I press F7, I press A, then I can write. Then I press F7 again. Ah, makes so much sense. This makes sense. Perfect. Okay. Okay. Under the hood cross term, don't care. Types in Rust. Let's talk about types now. Intuitively, a type is something that we can use to better reason about whatever we are talking about. Yep. And in chapter 2, we saw that the type of a data point in memory determines whether Rust treats this as an integer or a character A. The first type we encountered was therefore a char, representing a single character. You might remember that even this seemingly innocent basic type is already fuzzy, as our intuitive understanding of a character differs from Rust's understanding. I never learned how to write a carriage return at school, for example. In chapter 4, we are going to explore chars in more detail and discover that char in Rust are actually UTF-32 encoded. Up until here, we encountered a few types but never really commented on them. Char, as discussed above. Editor and terminal are types we have defined ourselves. A result is a type which represents either the pink box labeled OK or the black box labeled error. stdio error is a specific error type for errors that can happen during input or output operations, in our case when reading from the terminal or when writing to the terminal. Then we have seen various kinds of so-called enums. An enum is a list of different variants that something can have. Cross terms key code is an enum, which represents all kinds of potential keys that can be pressed. There is a spectrum which defines how strict a programming language works with types. On the one side of the spectrum, you have languages like JavaScript, which really do not care about types at all. If you want to call the method foobar on anything, it won't complain. It only checks once it gets to that code if this anything even has a method called foobar. This is called weak typing. And on the other side of the spectrum, you have languages like Java, which require you to be very deliberate with your types and try to protect you from calling methods on invalid types. This is called strong typing. There is also a middle ground with oddities like TypeScript, which brings strong typing to JavaScript, or Groovy, which brings weak typing to Java. Rust is firmly on the strong type side of the spectrum, but if that's true, why did it take us until the last third of chapter 3 to fully encounter them? Why, for instance, were we allowed to write the following in our main earlier, let editor equals editor default? There is no trace of the type editor, yet this compiles. Rust tries to be very accommodating to developers here. It infers the type wherever it can. And since there is no way that editor default returns something other than an editor, we don't need to make it explicit in this assignment. So Rust can trace the type if it is obvious, right? If it is obvious, it will get the type. But if it is not obvious, it needs a type. We as developers have to be less verbose in what we write, and should we change the return value of default, we would have one less code piece to touch for this update. We can sometimes have to make the type explicit. If we wanted to make the assignment above explicit, we would write editor:editor. This way if we change the return type of default, the compiler asks us to also change the type of editor. This is called type inference, and Rust can do that because we explicitly need to mention where it matters in function signatures. For example, our function signature to move the mouse cursor looks like this. Function move cursor to gives a result of an std of okay. What follows can be accessed outside of this file. What follows is a function. Move cursor to is the function name. X, Y. U16 is unsigned integer 16-bit. This ends the definition. What follows is a description about what this function will return to the caller. Result. This function returns a result which is one of the two possible boxes labeled OK or error. What follows is a definition of the two boxes. It is okay. An OK box will contain nothing, it will be empty. An OK box will contain nothing and it will be empty. An error box will contain an error of type stdio error. Integer types. Let's take a look at the new type U16, which we have seen cross term using and then utilized in our own code. This is one of the multiple types to represent numbers. As you might have guessed from the hidden complexity around char, where we haven't seen the end yet, numbers are also not easy to handle. First of all, we need to separate integers from other numbers like fractions. Remember, in storage everything is just zeros and ones, so if you're dealing with the fraction, you have to reason about how you can actually represent them in memory, which isn't trivial. Luckily, we are dealing with integers here. They are easier to handle than fractions, but still they also come in multiple flavors. Let's meet them in a Rust playground first, so you can experiment with them. So we have a function main. There is a u, small u, medium u, large u. I think these are unsigned integers. Extra large, okay. And then there is an integer which can take negative values as well, and then there are extra, okay. These represent the bits. So for example, the max value of small i8 will be like 1 bits, whatever that is in decimal. Let's start with the distinction between 816. By width, I mean how many bits are used to done. Okay. Yep. The U16 means a width of 16-bit. which yields us a more impressive 65,536 different values. Rust even has integers as wide as 128-bit, resulting in these different combinations. That's between one undecillion to one duodecillion. So why not be safe on the side and always use the widest integer type? The answer is performance. Smaller units can be processed more swiftly by a machine. A 32-bit machine is called like that because it can handle 32-bit operations efficiently. Any bigger data type would have to be handled differently under the hood. Decreasing performance. It follows that you sometimes might want to use the widest type available on the machine, for example 32 and 64. U size and I size respectively. We will discuss and use these a bit later. The other distinction between integer types is denoted with the letter I for signed integer or U for unsigned integer. The sign this refers to is the minus in front of it. If an integer is allowed to be negative or not. Let's get back to my awesome 2-bit integer as I told you. It can represent 4 different values, but which ones? If I decide for signed integers, it would represent -2, -1, 0 and 1. By convention, the range is a bit wider on the negative side. Okay. How? Okay, for a 2-bit integer, this means that in scenarios where I do not expect negative numbers, an unsigned data type yields me around the double amount of numbers. Cross term uses the type U16 to place the mouse, so an unsigned makes sense. So we won't ever expect negative coordinates. Cool. Better drawing of tildes. The next assignment are a few under the hood improvements. For starters, I am unhappy with how we write to the terminal. We used the println macro in the past and switched to print in the previous step. But we are also using cross term, where we use some construct using a macro called execute. This is bad for 3 reasons. 1. It irks me that we are mixing 2 concepts, direct printing and cross term. For me, this irking is like something that smells when you enter a room. This is usually referred to as a code smell, something that possibly indicates a deeper problem. We don't understand execute yet. We simply used it because the documentation told us to. That also smells fishy in my opinion. And 3, printing is weird sometimes and our code doesn't account for it. Let's start with that last part, how weird printing is. Printing to the screen is an expensive operation, and to make this more efficient, there is a concept of a buffer. Whenever you try to write on screen, you actually write to this buffer instead, and this buffer is emptied either if you do it manually or if the buffer is full. We didn't run into this issue yet. Usually the buffer is line buffered, so it automatically writes out at the latest if a full line is in the buffer. All our printing so far has included new lines, so we didn't see that issue. But writing the escape sequences does not necessarily print out a new line. Means that at that point we might be subject to buffering issues. Which brings us to the second part, the fact that we don't understand what we are using. Execute is actually a macro that ensures that whatever you pass it to it is printed out immediately. That's half great. It's almost what we want, but as I mentioned above, writing is an expensive operation, and we really only need to fully write to the screen after we are done with evaluating the key press. We do not need a full write for every cursor placement. Clear screen or write can leave it up to the buffering mechanism and can leave it up to the system to figure out the best timing to write each of these things. This could even lead to weird flickering effects if we write out every small change all the time. And this brings me to the first point, the code smell. Investigating that code smell has lead us to read up on execute and uncover how weird printing can be. And the result is that we now understand that our code only works the way it works by a lucky coincidence, and that is it is not working very efficiently. There is another possible source of the annoying flicker effect we should take care of now. It's possible that the cursor might be displayed in the middle of the screen, somewhere for a split second while the terminal is drawing to the screen. To make sure that doesn't happen, let's hide the cursor before refreshing the screen and show it again immediately after the refresh finishes. Then instead of clearing the entire screen before each refresh, it seems more optimal to clear each line as we redraw them. Here's the full assignment. Hide the cursor before you refresh the screen by using hide. Show the cursor after you are done refreshing by using show. Okay, let's open these up. Clear only what you intend to redraw by using an appropriate clear type. Refactor the current implementations to no longer directly use print but use cross terms print instead. Refactor the current implementation to no longer use execute, use queue instead, which you can use exactly the same. You'll need to manually ensure a write by calling stdout.flush to trigger the write at the appropriate time. Hint, to call this you need to use stdio write. Bonus refactor. Size returns a pair of two ordered values called a tuple. Wouldn't it be nicer if we somehow worked with the struct so that we could make it more explicit which of the two values is the height and which one is the width? Move to works with the two parameters to denote the x and y position. Wouldn't it be nicer if we somehow worked with the struct so that we can... Okay, so he's trying to say that I should write a struct for the coordinates and height and width of the terminal and also all of these things. Okay, so the first point is hide the cursor before you refresh the screen by using hide. So where am I refreshing the screen? In here, right? In the loop. So I should use hide here. Let's see what is hide. Pub struct hide. It is part of cursor hide. Okay, what is an example of this example usage? Nope. So if I go here, what? Hide, right? Let's ask ChatGPT how to use cross term hide. Oh, stdout.execute. Okay. Hide the cursor, refactor to no use queue instead, which you can use exactly the same. So what do we need to do? Queue is one or more commands for further execution. Queue cursor hide, right? You'll need to manually ensure a write by calling stdout.flush. Self.refresh screen. Hide the cursor before you refresh the screen. Show the cursor after you are done refreshing the screen. Okay. So either I can do it in here, but since this is kind of a part of the refresh, I should do it here. So I'll write in queue and I'll say cursor hide, and then at the end, what should I do? I'll do q cursor show. Clear only what you intend to redraw by using an appropriate clear type. I don't know what that is. Refactor the current implementation to no longer use print but use cross term sprint instead. Okay, let's see what is cross term sprint. It is a command that prints the given displayable type. So we shouldn't use print anywhere. For example, here we are using a print, but if I do this print, cross term style print, right? Yeah. Yep. I believe the implementation is kind of the same. Yeah, we'll see. What is this? Weird question marks in AstroWin. Question marks in AstroWin. Yeah, these types of question marks. I've installed a nerd font and dev icons via Vim plug. Set encoding equals UTF-8. Astro Vim question marks. Wait a second. Astro Vim icons. Yep. Did you also install a nerd font in your terminal? You might need nerd fonts. Why are my icons missing? The font requires correct lifts. For that, use a pre-patched font. Okay, how do I install this, guys?
arbitrary control of critical vehicle functions.
I'll just do these changes and I'll end the stream there. Maybe I'll play CS2. Yeah, I'll play CS2 for a bit and then I'll close the stream. Thanks for watching.